All right, this topic is about logarithms, so we're going to take a look at a refresher on how to use logarithms. Our first question, the function f of d is 93 times the log of d plus 65. It's representing wind speed near the center of our tornado, where d is distance in miles. And the question is, suppose there was a tornado whose wind speed was 240 miles. Now, this equation is designed to talk about wind speed, so that means that this 240 correlates to the wind speed here. And it struck a region in southern Illinois. How far did it travel? So it's basically asking, if our equation's equal to 240, what is d? What is the distance? So all I have to do to solve this problem is get d alone. And we're going to start by isolating the logarithm. I want to get the log part by itself so that I can figure out what's happening with d. So the log here is getting multiplied by 93 and having 65 added. So I'm going to undo those in the opposite order. I'm going to subtract 65 from both sides first. So 240 minus 65 is 175 equals 93 times the log of d. And then we're going to go ahead and divide both sides by 93. So the log of d by itself is equal to the number 1.882. And I want to figure out what that d value is by undoing this log. Now, if I have something written as a log and I have something trapped inside a log and I don't want it there anymore, I have to rewrite it so it's not a log anymore. And we do that with a log rule, if you recall. And the log rule says that we take the base. We don't have a base here. If we don't have a base, that means it's automatically base 10. So we're going to do base 10, and we raise it to the power of whatever's on the other side of the equal sign, so 10 to the 1.882 power, and it equals whatever was inside the logarithm, so equals d. So all I have to do is 10 to the power of 1.882 in the calculator, and it tells me that d is 76.208, and it says round to the nearest tenth, so 76.2. And it's measuring distance, so we could say it's 76.2 miles. Awesome. Okay, let's go ahead and take a look at this equation. We're going to try and find the value for x. This one's an exponential function, and I'm going to have to use a logarithm in order to solve it. Remember, logs and exponents are opposites of each other. So given the following equation, what is the value for x? X is in here as an exponent, and I don't want it there. So the very first thing I'm going to do is isolate the base. I want to get the 7 to the x minus 2 power by itself, and it's being multiplied by 4, so I'll divide both sides by 4 to start. So 7 to the x over 2 power is equal to 96 over 4, which is just 24. Now I have this stuck in a logarithm, and I have two methods that I could use in order, it's stuck in an exponential. I have two methods I can use in order to get this by itself. I'm going to go ahead and show you both. The first one is to take the log of both sides. So I'm going to use a logarithm to rewrite this. So I have the log of 7 to the x over 2 power, and I'm going to do the log of 24. Now the reason that's helpful is because exponents get to move to the front of a logarithm. So that means that this is going to be x over 2 times the log of 7, which is going to be equal to the log of 24. And all I have to do to start getting x alone is to unwrap it here. So divide both sides by the log of 7, and then undo the divided by 2 by multiplying both sides by 2 times 2 times 2. So if I type in 2 times the log of 24 over the log of 27 into the calculator, it'll give me my answer. Now the other thing that I could do here, which I can use to get the same exact answer, just like I used a log roll in order to undo a logarithm when I didn't want a log anymore, I can use a roll back in order to write this as a log instead of an exponential. And in order to do a roll back, I start with the base, 7, that's going to be the base of my log, of the number on the other side of the equal sign. Oh, 7 is the base of my log, not the number inside my log. Log base 7 of the number inside on the other side of my equal sign, so of 24, and it's going to equal the number in my exponent equals x over 2. So in order to type this in the calculator, I would need to use the change of base formula, which says the log of my top, the bigger number, 24, gets divided by the log of my base. Remember, the base goes to the bottom. We drop the base over the log of 7 equals x over 2. And again, to get x alone, I would multiply both sides by 2, and I would still have to type into my calculator 2 times the log of 24 over the log of 7. So it doesn't matter which way I do it. I get the same thing either way. And if I do that, then x ends up being alone as the number 3.266. Remember, your calculator, you can only type in log base 10, although we are going to see one question here. Eventually, I believe we see a natural log. Natural log just means that so it's going to come up in question 38. We'll see that in just a second. Your calculator only understands 2 logs. It understands log base 10, and then another log we didn't really get the chance to talk about in class, which is in the review, just so you get an intro to the concept. But again, the test is so heavily curved that everything we didn't talk about won't really affect your grade for the final exam. Excuse me. All right, up next for question 37, you can start this question in 2 different ways. You can either start by squishing your logs together or by just trying to isolate x, and it doesn't matter. I'll go ahead and show you both ways. On the left, I'm going to start by smushing these logs using log properties. When I have 2 logs with the same base and they're being subtracted, I can smush them together into one giant log if I use division. So the things being subtracted end up in a fraction. The negative one, this one being subtracted, would go on the bottom. So 4x plus 8, and the 3 is being subtracted, so it would go on the bottom. So now I have one giant logarithm. Once I have one giant log by itself on one side of the equation, I can use a log roll in order to get the x out of the logarithm. So I'm going to start with my base, which is the number 10, to the power of what's on the other side of my equal sign, and it's going to be equal to whatever was inside, 4x plus 8 over 3. And this is the equation that I end up with. This equation, 10 squared is 100. I would have to multiply both sides by 3, so times 3 is 4x plus 8. So I get 300 is 4x plus 8. I would have to subtract 8. So 292 is 4x, and then divide both sides by 4. So 292 divided by 4 gives me 73. Now, if I don't decide to smush them into one giant logarithm first, that is fine. I can still solve for this. The log of 3 is just a number, and my x does not have anything to do with the log of 3. What I'm having is this log of 4x plus 8, and I'm subtracting this number called the log of 3. So if I want to get the log with x in it by itself, I can start by just adding the log of 3 to both sides to get it away. So I have the log of 4x plus 8, and I can add the log of 3 to both sides. So 2 plus the log of 3 to kind of just get it away. And now that I have my logarithm isolated on the left-hand side, again, I get to do my log roll. And it starts with the base, which is 10, to the power of everything on the other side of the equal sign. Everything. So 2 minus the log of 3. And it's going to be equal to what was inside my original logarithm, 4x plus 8. Now, if you do 10 to the power of 2 minus the log of 3 in your calculator, it tells you that that number is 300. Fancy that. So 300 is 4x plus 8, and again, all I have to do is subtract 8 from both sides. I get 292, divide by 4, I get x equals 73. So it doesn't matter which way you begin it, you get the same answer either way. So it's basically up to your comfort level, but using these properties of logs can be absolutely helpful. So if you decide to do that, that is awesome. All right, we have one more logarithm question, and it is using this letter E here, which I know we didn't really talk about in class a lot. E is another base for a logarithm, and if I do log base E of something, I end up with what we call the natural log, which is written as ln, and you'll see ln in your calculator. It's the only other base that your calculator understands. Your calculator understands log base E and log base 10. So in order to undo a base that's not written, we use 10 to the power of. We use 10 as the base in our log roll. If I have a base that's not written and I see ln, that means that the base e is happening, and I can use e in my log rule. So let's take a look at what happens here. So we have e to the x plus 1 power equals 30. Now, when I had 7 to a power up here, I did the log on both sides because I had just a regular number. So I used base 10 in order to justify that. When I see that e is my base, instead of using log, I'm going to use ln. So the same kind of thing happens, but I'm going to do ln on both sides. So I'm going to do ln to the of e to the x plus 1 power, and it's going to equal ln of 30. So ln and e undo each other. The same log rules apply, it's just a different base, so this exponent can move to the front. So this is x plus 1 times the ln of e, which is going to equal the ln of 30. And the ln of e is a very special number, just like the log of 10 is a very special number. If I do the log base 10 of 10, it's asking what power do I raise this base 10 to turn it into the number 10, and the answer is just 1. So the log base 10 of 10 is 1. The same thing happens with ln. So ln is the log base e, and if I do the log base e of e, it's asking what number do I raise e to turn it into the number e. The same number I raise anything to turn it into itself, which is 1. So the ln of e equals the number 1, which is why we use the ln in this case. So the ln of e is 1, so this becomes just the number 1. So it's x plus 1 times 1. So x plus 1 is now just by itself. And it equals the ln of 30. All I have to do to get x alone is just subtract 1. So x equals the ln of 30 minus 1, which says to round to the nearest thousandth, so x is going to be 2.401, and that problem's finished. The only difference between this and a log problem is if I have an exponential function with a base that's a number, I do log on both sides. If I have an exponential function with e as a base, I do ln on both sides. That's the only difference there. And if you can remember that one thing, you can deal with exponential functions with e as a base with no problem on the CFE. Now again, if that was confusing for you, don't worry about it. The CFE is so heavily curved that missing a question about something we didn't cover will not hurt your grade. Just make sure that you're solid on the rest of the review and don't stress about it, okay? All right, make sure you work on the rest of your review.